and I have been working as a software engineer at New Relic for about the past year and a half now. I am here today to talk about a time when I looked deep into the time vortex and thought about it. It is a tale of failure, but also of redemption. So I'm going to tell you about the mistakes that I made so that you can make different mistakes when it comes to time zones instead. So here's my plan for today. I'll talk a little bit about why time is hard for programmers to deal with. I'll go over the problem I was trying to solve, how I thought I would try to solve it. And then I'll dissect what the code for that looked like in my multiple attempts at a solution. So, show of hands, who's already had to deal with time zones in coding in the past? Oh, okay! Cool. So, we're among friends here. That's cool. And what about people that are just sort of have learned through osmosis that time is like there are dragons involved? Okay, cool. So, hopefully you get some use out of that and you guys make different mistakes. So, just so that we're kind of on the same page, I wanted to pull out a couple of fun examples of why it is that dealing with time zones can be pretty finicky. So here's one, in that it turns out Argentina didn't used to do daylight savings at all. Yeah. But then for a couple years, the government was like, oh, let's experiment so that we can try to save energy, maybe. And so for each year that they were doing daylight savings, the government would set the start and end dates for it, which means there wasn't a fixed annual schedule that you could program some logic for. It was completely arbitrary. Which is how I feel about that. Here's another fun one. I found this in the documentation for the active support port extensions, actually. So in October 1582, it turns out that days 5 to 14 just don't exist entirely. This oddity is due to when there was the switch from the Julian to the Gregorian calendar. Okay, now that we know that historical bit makes sense. And the funny story I read about this is that when it happened, people actually thought that the church was literally stealing days off of their life. They thought that they were going to end up dying 9 days sooner. Wonderful. So no assessment has a couple of really great blog posts on the many false assumptions that programmers make about time. Some of my favorites are that even though there are usually 24 hours in a day, there aren't just 24 time zones, because the time zones aren't just an hour apart. They can be 30 minutes apart, 45 minutes apart, all sorts of other intervals. And another great one is that time doesn't always go forwards. If you want to hear more about that, go check out those blog posts. The slides will be up afterwards. All right, so really we can conclude that, it really is just this big ball of wiggly wobbly time stuff. And so that brings me to our first lesson, which is to trust nothing, including Argentina. I don't mean to, if there's any Argentinians that are going to pick on you, it's happening. Anyhow, if you want more proof, here's another example from a RailsConf solve. We do a simple comparison, 1 month to 30 days, and we find that, yes, those two are equivalent. And then we try to get today's date, or the date at the time I was writing this slide together, and that was Thursday, April 9th, fair enough. Let's do some math. We do 1 month ago from today, and we get March 9th from April 9th, fair enough. And then if we go ahead and do that date minus 30 days, which remember, these two are equivalent, the answer is in fact not the same. So, just to remember, trust nothing, including Argentina, and including math. Trust it either. So I'm going to talk a little bit about the problem that I was trying to solve here. At work, we have a feature to send weekly email reports to our customers, because, as we like to say, Mondays need a little bit of help. This is set up with a cron job that queues the weekly email jobs for each account that then run in order to build and send those email reports. And so in this way, we have a separation between scheduling something versus executing it, or what you're doing versus when you're doing it. Now, we would run this cron job that kicks everything off on Monday mornings at 10 a.m. Pacific time. And the reasons for this are historical. New Relic is a company that started in the Pacific time zone. And so this is the kind of thing that it makes sense when you're small and you don't have that wide a spread of customers. Also at New Relic, we have a culture of people not working on the weekends. And so it's nice to have something like this on Monday morning in case there are any problems, so people can look at it then and not have to be checking things over the weekend. However, even with starting at that 10 a.m. for us in Pacific time, we're already well into the current business week for much earlier time zones, such as Tokyo, where the entirety of Monday has already passed for this report that they're supposed to get on Mondays. In addition, New Relic has grown to have many more accounts than when it first started. And with more and more emails to send out, it was taking longer and longer to finish all of those jobs, which led to even more customers receiving their Monday weekly report on Tuesday in their own time instead, with weekly summaries that were offset from what they would expect. So here's our proposed solution. It's a Monday morning report. People should get it by their Monday morning, not ours. So here's a sort of sample of some potential accounts and time zones and what it would mean for us in Pacific time of when those reports should go out. And I set it at 1:01 a.m. to avoid any weirdness potentially being at the top of the hour. And so this is, again, the setup for the whole thing that we have here. We set them up to run at 1:01 a.m. local time. And since some of those earlier jobs would have to be running on our Sunday, we'll kick off the whole process a lot earlier on Saturday in order to get ahead of them. There's another nice bonus here, which is that the reports will get sent out spread over a day, rather than trying to queue them up all at once. And so we can smooth out that big spike we used to see on our background here every Monday morning, and have fewer alerts there. So here's my first attempt at solving this. The first question I had is, what date is the next Monday? And in this case, playing around with the console, I saw, okay, we have a date library, we can get today's date, and we have this class date time as well, which is with this method parse, so we can feed it a day of the week and a time, and it creates a date object out of it. And so here we've gotten Monday, 1:01 a.m., Greenwich Mean Time. Cool. So now that I have that, all I need to do is convert it into the local time zone for that account. So I'm going to do a quick overview of some relevant time and date classes that you might end up using in Rails. First, RailsConf has used a gem called tzinfo to be able to convert times between different time zones with daylight saving taken into account. The built-in data source for that is the IANA time zone database. And it's updated every so often to reflect changes made to time zone boundaries, any changes to UTC offset, or daylight saving rules. And so you might think that this is pretty static, but it updates quite regularly, actually. This is 22 updates in the last 3 years. And so you need newer versions of tzinfo to keep up with these changes. But incidentally, Active Record pins that tzinfo version, so you can't actually update it without updating Rails, unfortunately. You know, if you're in a situation where we're working on it, but yeah, we'll see how that goes. Anyway, there's also this other helpful useful class of actor support time zone, which is a wrapper around the tzinfo time zone instances. And among other things, it lets us limit the set of time zones from tzinfo to a, quote, meaningful subset of 146 out of the many, many more that are available here. And so if you compare this map of the 24 bands of time you'd expect globally with this list in very tiny font of all the time domains you might be able to get access to. And so speaking of which, another thing that you get out of this is friendlier time zone names, so that instead of having something like America/New York, you can call it Eastern time instead. And so if you want to play around with this in your Rails console to try to get some of those time zone names, you can run something like this, where I just mapping and collecting those values and filtering them for a specific offset. So here is the list of time zones with the +12 offset. So these are very early time zones, often Wellington, New Zealand. And And then some very late time zones, -11, like International Dateline West or American Samoa. You might have noticed when you play around that there actually isn't a time zone listed in there with UTC -12 as the offset. And this is because that time zone covers the Baker and Howland Islands, which are uninhabited, and so they are not considered part of the meaningful subset of Anyway, back to our question of how do I get that date time into the local time zone? Well, that active support time zone class provides us with this method, local to UTC, which, given a time zone and a date and time, it'll convert it into UTC time for us. So, very useful. So this is what the method ended up looking like for this first attempt here. We have this method signature that takes in the account time zone. I'm just going to pass that in. We use that date time dot parse to get us the next Monday at 1:01 a.m. If for whatever reason that account doesn't have a time zone set, we're going to use a default of Pacific time, which is the behavior that we had before this change in case. And then we'll just go ahead and use that local to UTC method to get UTC we want this job to get in. Pretty straightforward. So tests, of course, we have to have tests. And so when you do testing related to time stuff, it's useful to be able to freeze time or travel forward when you want to have a consistent time frame for these tests. Basically, it lets you spoof the system time. And TimeComp is a gem that you can do this with. Rails 4.1, I think, actually has some time travel stuff already built in. But again, we're not quite up to that version just yet. So your test will generally follow this kind of setup, where you freeze time at a specific time, and then you'll have your tests. You also have to make sure to have this teardown in there after your tests are done, because otherwise, when you run them, you'll get stuff like this negative time here. This is enormously large in your time. And that will leave you feeling like that. Anyway, the tests then are set up that I wrote looks something like this, where it was nice to have this datetime.parse in there so that it makes the date and time we're looking at pretty easily readable for the next developer that's in there. And I just have a test here for a time zone west of UTC Mountain Time, saying, this is the exact date and time I expect to get out as a result of this method. So, fair enough. So that's one time zone on the west, and then I also picked a time zone on the east of UTC Bangkok time, just randomly to have it in there. And everything passes. Awesome. We also talked a little bit about some scheduling changes that needed to be made. And so just as a reminder, this is the setup that we've had before, where everything is just queued up immediately, and the queuing job starts out at Monday at 10 a.m. And this is what we want it to get to, where each one is queued with this local 1 a.m. time, and the whole thing gets started off on Saturday. So pretty straightforward to changes to start on Saturday morning instead. Just sort of say, like, it's a daily crop up at random. So if it's Saturday, go ahead and run this script to start queuing up these email jobs. And when that happens, the jobs are now using this .enqueue at versus .enqueue. The enqueue at lets you pass in that UTC timestamp of once this time is in the past, you start running this job. And overall, it just really didn't seem like that big of a change. I got it reviewed by a couple of people, and everything looked good. It was a total failure. Instead of queuing up a bunch of emails to be sent throughout Sunday and Monday, we started seeing tons of emails getting sent immediately on that Saturday morning instead. And these emails didn't even really have useful data in them. I was at a conference at the time, actually, and I had to run off and find a phone room and get help from a coworker who really should have been spending time with his family instead. And then we had to go into the servers manually to run this, and it was just the worst. So I'll go over why exactly this code failed, as well as how I ended up fixing it, but here are a couple things to think about first. Lesson number 2 here is that I really should have set it up so that there would still be a way to trigger the reports to run immediately without that time delay schedule, and without having to run that command completely manually. It's really hard to watch out for pitfalls that you don't know are there, and as we've already discussed, there are a lot of those for time-related things. And so to counter the worst-case scenario, you should assume that you're going to mess up something and have a plan for what you'll fall back to. It's like one of those semi-inspirational quotes that I really like, which is, let's try to make better mistakes tomorrow. It's not going to be mistake-free, but we can at least not make the same mistakes that we did before. And also, of course, after all of this had happened, I then finally thought of a way that I could have rolled out this change in stages rather than all at once. I could have set it up with some of our internal accounts to do a bit of a test run and have it run through the whole system then to see whether it would work. So what happened here? That week's emails ended up being queued up for 1 a.m. local time for the last Monday. So it was already in the past, and that's why they started running immediately. And the problem that we have here is that the code couldn't tell whether it's the closest date or the last date. So if we take a look at some of the results in the console here, date that today, is that Thursday, when I was putting the slide together. So let's say that that's that Thursday on the calendar there. And when we put in that datetime.parse for Monday 1:01 a.m., what I wanted was this Monday in the future, but what I got was this Monday that had already passed. And so this brings us to lesson number 4, which is that today's console results are not, in fact, tomorrow's console results, especially if tomorrow is the start of a new week. Turns out, time methods are time sensitive. I was taking for granted my own current date when doing testing in the console, and I had just been taking it for granted as part of the environment. I really shouldn't have done that. But you had tests, you say. Yes, I did. The problem there was it turns out that datetime.parse isn't really friends with timehop's freezing and traveling time. So we changed the test setup so that we pick a very different date. In this case, it's just May 1st. Previously, the tests were around April. And then we freeze time then. May 1st happens to be a Friday, and the date that we want is May 4th, which is the date in the future there. I had assumed that datetime.parse would be context aware and somehow know to be giving me the next Monday. And so if I pry into the setup for the test then, it's correctly May 1st, which is what we had set for timehop. And if we go ahead and then run that datetime.parse for Monday 1:01 a.m., we in fact get April 6th instead of that May 4th that we were looking for. So that's pretty strange. And so when it turns out, if we look back at the test setup again, essentially, the timehop phrase didn't have any effect on the setup for the test at all. And the tests only passed because they happened to run in the right week, because I had picked dates that were right around the time, and I had picked these dates that confirmed what I already knew from running the console, and that this happened to work at this moment in time. So even after all the mess from that weekend, I came into work on Monday realizing that I had put a failing test on master, affecting everyone that works on that code base. And it was pretty sad. So that brings us now to lesson number 5, which is to guard against writing false positive tests. Even though my tests were passing, it was really a fluke that they were passing at all, and I should have been more careful in the tests that I wrote to catch more situations, rather than confirming what I already knew to be true. So now I'm going to go through a little bit of the actual solution that I ended up with. At this point I was like, oh yeah, TDD, that's like a thing, we can do that. All right. So that first step there, where we have these tests before, very first thing, fix them to use dates that aren't right around now, and have this be an actual test. So I'm just picking some random dates. These happen to be some dates in February, April. And I also decided at this point, to make it easier for the next person to read it, I'll add in just a quick sanity check that this new date I picked is in fact a Monday, given what we're trying to do here. And so just so people don't have to go through and look up what day of the week was February 10th, 2015. And this does in fact now start failing and demonstrates that it should be had of datetime.parse and timehop not being printed each other. So now I need another way to get that next Monday besides this really simplistic use of datetime.parse. But also thinking back to that lesson number 2 of having a backup plan, I realized, we might need to run this script after a Saturday if that Saturday job fails. And so this is the ideal scenario, where if everything goes well, we run the script on Saturday morning, all the reports are set up to run in the future still for their local time Mondays, and the report should cover that most recent week. But if something fails though, which we know we need to plan for, we might need to run this script later, like on a Sunday, but it should still pick that same Monday and run the report for that past week. And additionally, if you think about it, at some point though, we're gonna have to transition so that if you're running the script later in the week, it knows to set up the reports for early the following Monday, and that's that week of data. So we have this question of how do we distinguish between when we want to have this week versus next week? And it is kind of confusing to think about because there's a bunch of time frames that we're thinking of here. There's the one that you yourself have to be located in. For me, that was Pacific time. There's the service time zone, which who even knows, and by the way, server times apparently, you can't count on them to be accurate. Assumption there. And finally, the customer's time zone that we're talking about here, which could be ahead of us or behind of us at the time we're running this script. And so we need to have some kind of logic that applies globally. What I ended up coming up with was, if it's still Monday somewhere, anywhere, we'll think of it as this week still, for which week we want to run this report. And then once it's at least Tuesday everywhere, if we run the script then, it should schedule reports for that next Monday. Which is this final lesson 6 here, of figuring out a global, consistent logic. It helps make a lot of the edge case coding more straightforward. So this is what the method ended up changing to. We're going to go ahead and grab the today for one of the last time zones globally, that international dateline west we saw earlier. Very simply, we're going to do some simple math to figure out the days until the next Monday, day of the week. And then we're going to, as before, use either the account time zone or a default of Pacific time. And then we're going to use this formatted offset method. This returns the offset of the time zone as a formatted string, so like this, +7. And now that we have all those pieces, we can feed that into date.parse again with a specific date that we know is the next Monday, the time, 1:01 a.m., which is pinned and is going to be the same for all of the accounts, regardless of the date of the time. And then that number of hours offset for the correct time zone. And now finally, those original 2 tests pass. But if we learned anything, it's not enough coverage there, and there are some other scenarios we need to test out. So one situation that is very important for us still is whether we're inside or outside US daylight saving time. There's plenty of other edge cases, but for us, this would be a major one to cover. And when we do that, we do in fact find that there's one of the tests now failing here. If you look closely, we have, of course, an off by 1 error. And the reason for this is that formatted offset method alone doesn't care about daylight saving at all. It has no context of the current date. And so you need to add in this dot now in order to get it to take the date into account. And once we've done that, those tests are now passing. Okay. So essentially we've covered this normal case of when we're running the script to set up the weekly email jobs, and that's all taken care of now. But we had a couple other scenarios, like when we're running the script for the most recent past week, and it's gotten a bit late. We haven't been able to get ahead of the law on Saturday for whatever reason. And so to set up these examples, I'm going to use a really late time zone, American Samoa, and a really early one, Wellington, New Zealand. And in this case, what's going on is that it's already Monday in the customer account before the report even runs, but it's Sunday where we are. So that report should have really already run and gotten scheduled with a date that's in the past for the account. And so we're running it on June 1st our time, and it should parse to the 2nd of June. Fair enough. And fortunately, that still works. Awesome. And as another test along similar lines, let's say it's really late Monday globally, but it's still Monday somewhere. So we don't want to skip ahead to the next Monday. It should still stay on that same 2nd of June. Unfortunately, this test also passes now too. Awesome. And then finally, we need to test the scenario where we happen to miss the boat for that last week, and for whatever reason, we're running the script ahead of time on Thursday instead of Saturday. So with this one, we're picking a time where we know for sure it's Tuesday everywhere in the world, because it's already Tuesday in Samoa, one of the last time zones. And then we're going to check, what will happen for this Wellington account that we have scheduled here. And it should now be, rather than the 2nd of June, it should be the 9th of June. It should still always be in the future. And set it up there. And this method now works. And so if we look at the summary of the tests, before, when I initially implemented this, there are only these 2 pretty simplistic tests in here. And now we have much more detailed coverage of all the different scenarios of what we expect to happen there, which is also really useful for tests as documentation. Okay? So for me, I came up with this bit of a checklist for different tests to write in the situation anyway, these time zone related changes. I had initially already done covering a time zone west and east of UTC. I also did the pinning it down exactly when you're starting and when you're ending to make it easier to see what the expectations of those changes are. And this third bullet point, though, is the first thing that I should have done and I didn't do until the second round, which is picking those dates inside and outside of daylight. Oh, sorry, it's random dates in the future or the past. So just not current weeks that happen to be when I'm submitting this PR anyway. Just picking random dates at some point later. But also in addition to that, picking some dates that are inside or outside of daylight saving. And for greater clarity, I think that added check of making sure that the dates being used is as far exactly the expected day of the week is probably pretty useful for future readers of the code. As well as the scenario that we decided was pretty important for our backup plan, this test to trigger the script on different days of the week here. And finally, I didn't get around to doing this, especially as I was preparing this talk, but I really should also have a test for what happens on the actual dates of daylight saving transitions. And so it's possible if I wrote this test that I would discover some bugs in my code still of reports getting duplicated or skipped over potentially. And so finally, we have a couple of the scheduling process changes that we have as well. Reminder that you must have a backup plan. And so I set it up so that there would still be a way to have the jobs get queued up much in the same way that they were before, using that dotted queue versus dotted queue act with a time in case there was some undiscovered bug related to trying to calculate that time that we were going to be using that. So just with this queue later flag, I'd be able to trigger one pathway or the other. And also that lesson of doing an internal test run. The way that I set that up was, I have a couple test accounts in there, and I set those test accounts to be at opposite ends time zones, sample account 3 and 10. And I generated the reports to get sent to myself with that new code pathway option with that queue later flag. And when I emailed it to myself, I used this plus email test alias at the end, just so that when I received it, I know where I was getting it from. And put that in there to let it bake for a couple weekends before actually rolling this change out to production. And when I did that, my emails in Pacific time, and I did in fact receive these emails at around 1 in the morning local time from those accounts, 4:02 a.m. and 1:07 p.m. Pacific time, due to the offset between those accounts' time zones and my own Pacific time. All right. And so finally, as a summary of all the lessons we have here, lesson number 1, remember, trust nothing, including Argentina, and including that. Have a backup plan. Do an internal test run, if at all possible, so that if it fails, it's not quite so publicly visible. Remember too, as you're testing, that today's console results are not in fact tomorrow's console results. Do what you can to guard against writing false positive tests. Hopefully the checklist can help them do out. These are some of those situations. And then finally, figuring out a consistent global logic will go a long way in terms of clarifying what exactly you're trying to do. Thank you.